Watch what happens to this simple 2D circle. If we pull it straight up, it becomes a cylinder. Pinch the top, it turns into a cone. Puff it out perfectly, and we have a sphere. These complex shapes all rely on two core measurements: the radius across the base and the perpendicular height running right down the middle. We analyze them in two ways. The amount of space inside, the liquid required to fill them up, is the volume. The wrapping paper needed to cover the outside is the surface area. Welcome to BIJU at Educator. If you are prepping for your Class 10 board exams, hit subscribe right now because we are breaking down 3D geometry step by step. Staring at a textbook trying to memorize a list of variables usually leads to a blank mind during a test. But when you visualize the physical properties of these shapes, you can derive the exact formula you need for any problem. Take a look at this unrolling cylinder. The curved exterior is actually just a flat rectangle. The length is the circle's circumference, 2 pi r, and the width is the height, h. Multiply those together and your curved surface area is exactly 2 pi rh. Now watch this animation. It takes exactly 3 identical cones to fill up one cylinder with the exact same base and height. That physical relationship proves the formula. The volume of a cone is simply 1/3 pi r squared h. Surface area in cones requires a different approach. You cannot use the straight-down perpendicular height to measure the outside mapper. You have to measure the sloping outer edge, which is called the slant height, or L. By making the cone transparent, we reveal a right triangle formed by the radius and the perpendicular height. Because of that, you can calculate the slant height anytime using the Pythagorean theorem. L equals the square root of r squared plus h squared. Isolating that right triangle ensures you use the slant height for the surface area, rather than the perpendicular height used for volume. Let's look at the sphere. Its total surface area is 4 pi r squared. Slice it exactly down the middle, and the curved bowl that remains is half of that original area, 2 pi r squared. That is your curved surface area. Cutting the sphere exposes a new flat circular face on top. To find the total surface area, we must add that circle, pi r squared, to the curved bowl, resulting in 3 pi r squared. Let's test this rule. Calculate the total surface area of this hemisphere with a radius of 7 centimeters. Use 22/7 for pi. The answer is 462 square centimeters. Missing exposed faces or counting hidden faces is the fastest way to drop points on an exam. Now we apply this to a real board exam scenario. Watch what happens as this cone connects with the top of our hemisphere to create a single solid toy. The exam asks you to calculate the total surface area of this new shape. If you just add the total surface area of the cone to the total surface area of the hemisphere, your answer will be wrong. When these two shapes merge, their flat bases push together and are completely sealed inside the object. To calculate the surface area correctly, we only measure what we can touch on the outside. On the top half, that is only the sloped exterior, so we use the curved surface area of the cone, pi rl. On the bottom half, we can only touch the outside of the bowl, so we use the curved surface area of the hemisphere, 2 pi r squared. Combine them, and the total surface area for the toy is simply pi rl plus 2 pi r squared. The hidden interior circles are completely excluded. This matrix shows every single formula we just proved visually. Pause the video and take a screenshot now. Keep it handy while you practice. When you trade rote memorization for visual logic, the math finally works for you. If any of these shape combinations are still tripping you up, drop your questions in the comments below. Make sure to hit subscribe at biju.educator, like the video, and share it with your classmates. Let's conquer the rest.